Hello everyone. Previously, we have learned 4 basic properties of logarithms. The first one is log base b of 1 is always equal to 0. Of course, given the condition that b has to be positive and b cannot be 1. Then we have log base b of b is equal to 1. Third basic property, log base b of b to the x is equal to x. And then last but not least, b to the power log base b of x is equal to x. Today, I'm going to introduce 3 new properties. They are called the product, quotient, and power properties. These are very important properties. It'll help you solve equations later. Let's talk about the product property. For any of these properties, we want to make sure that the conditions are met. b, x, and y all have to be positive numbers, and b cannot be 1. So product property is, if we have log base b of x times y, since nothing is written in between x and y, we assume that that's a multiplication symbol. Then this is equivalent to log base b of x plus log base b of y. I know it seems a little strange. We have multiplication here, but then we end up with addition here. So it actually has to do with the formula b to the m times b to the n is equal to b to the m plus n, where you add the exponents. This is one of the exponent properties that you might have learned earlier. Now, I want to point out some common mistakes, and then we're going to do some examples. So, common mistakes with this formula is sometimes students will mistaken that if you have log base b of x plus y, that is equivalent to log base b of x plus log base b of y. But it doesn't work that way. Also, another mistake, log base b of x times y is equal to log base b of x times log base b of y. Both of these are incorrect. Again, the correct way is you have x times y here, and then you end up with the sum of 2 logs here. So how does it happen? We're going to prove this formula. So let log base b of x is equal to a value, say m, and log base b of y is equal to a value n. Using the definition of log, we're going to convert this to an exponential expression. So b to the m is equal to x, and b to the n is equal to y. Let's write that down. b to the m is equal to x, and over here, b to the n is equal to y. So when you have log base b of x times y, that's the same as log base b of b to the m times b to the n, because that's what x and y equal. Then we have log base b. Now, remember the exponent property. Apply that for this one. We have b to the m plus n. You add the exponents. Now, I can also write it this way without the parentheses. And you should be able to recognize that this right here looks like this formula, property 3, where if you apply the property 3, this will equal m plus n, which m, remember, is defined as log base b of x, and n is log base b of y. We define them up here. So in the end, I just showed that log base b of x times y is equal to log base b of x plus log base b of y. And we use property number 3 from the basic properties. So let's apply this formula in some examples. We have log base 2 of 8 times x. So that is equivalent to log base 2 of 8 plus log base 2 of x. Now it is our responsibility to make sure that everything is simplified. So log base 2 of 8, that's the same as log base 2 of 2 cubed plus log base 2 of x. And log base 2 of 2 cubed, again using property number 3, this will become 3 plus log base 2 of x. Simplify log base 2 of 8. You could also let it equal to y, and then you use the equivalence property. So we have 2 to the y is equal to 8, and 8 is the same as 2 cubed. So we can conclude that y is equal to 3. So therefore, this is equal to 3. And that's what we have here. Next example, log of 10 times x. Now this is a common log or log base 10. So we can rewrite this using the product property. That will become log of 10 plus log of x. Now log of 10 is equal to 1 because log base 10 of 10, we can use property number 2 here. I'm going to make a little mark here. We use property number 2 to cancel that down to 1, and then 1 plus log of x. Next, we have the quotient rule. Log base b of x divided by y is the same as log base b of x minus log base b of y. So we have a quotient that becomes a subtraction. It's related to the formula b to the m over b to the n is equal to b to the m minus n. To prove this formula is very similar, we're going to let log base b of x be m and log base b of y be n. Using the definition, we have b to the m is equal to x and b to the n is equal to y. So now when we take log base b of x divided by y, that's the same as log base b of b to the m over b to the n. And we can subtract the exponents in for b. And using property number 3 again, that will simplify down to m minus n. Again, property 3. And m was defined at the beginning as log base b of x, and n was log base b of y. So we just showed that log base b of x divided by y is equal to log base b of x minus log base b of y. Now let's apply the formula. First example, log of x over 1,000. This is log base 10. So this can be written as log of x minus log of 1,000. And that is log of x minus log of 10 cubed. And you can insert a base 10 here if you want. But log base 10 of 10 cubed should become 3 using property number 3 again. Next example, we have, this is the natural log, ln of e over 12. That's equivalent to ln e minus ln 12. And ln e is equal to 1 using property number 2. Basic property number 2. And that is because you can insert the base e here, and you can see the base and the input are the same. So that will become 1. So the final answer is 1 minus ln 12. Next, we have the power property. log base b of x to the p, this will equal p times log base b of x. Think of it as if you have an exponent here on the input, then you can pull it to the front and times it by that log. So this has to do with the exponent property b to the m, and then to the p is equal to b to the m times p. So let's see. So let's prove this formula. So again, let log base b of x be m. So using the definition, b to the m is equal to x. So when we have log base b of x to the p, that's the same as log base b. Now x is defined as b or m to the b power. So that's m to the b power, and then raised to the p exponent. And at this point, we can multiply the two exponents together. And using property number 3 again, this will equal m times p. Again, using property number 3. Now, m was defined as log base b of x, and p is just a constant, so times p. We can put p in the front of the log, and then we have the formula, which shows that log base b of x to the p is equal to p times log base b of x. Let's try some examples here. So right now we have a radical. We can convert the radical to a rational exponent, an exponent that is a fraction. So that this will convert to the exponent 2 will be the numerator, and the index 5 will be the denominator, so x to the 2 over 5. Applying the power rule, we can pull this exponent to the front, so we have 2 over 5 times ln x. Next example, very similar. We can just pull the 2 in the front, and that will give us 2 times log x.